Okay, so remember, we're trying to see that if we have inequality symbols, if we add, subtract, multiply, or divide to each side, whatever you do to one side, you do the other, that still holds true, is our inequality symbol going to be preserved or reversed? So I'm going to go a little quicker. If you need to pause to write stuff down, feel free to do that. Okay, so we're at station 2 now. Remember, we're rolling some die, excuse me, some dice. And in this station, let's pretend that we're multiplying. Actually, we're not pretending. We really are going to be multiplying, okay? So here's our example. Excuse me. -3 is less than 4. And again, picture a number line. We can get you a number line if you need one. Talk to me. -3 is less than 4. True statement. But now we want to multiply by a -1. So you can see here, when we have parentheses together like this, okay, that means multiplication. We're multiplying each side by a -1. So we started with -3 is less than 4. But if I go -1 times a -3, that's a +3. If I go -1 times 4, that's a -4. +3 is not less than -4. So we take our inequality symbol and we reverse it. We flip it over, okay? So let's see if that holds true with what we're multiplying here by. Okay, so again, rolling some dice, I am going to get a 6 and a -3. So using a number line or knowing what I know about numbers, 6 is greater than -3. So what happens when we multiply each side by a -1? Okay, so if I go -1 times my 6, again, keeping in mind that when we have the parentheses right next to each other, that means multiply. Is that still going to be greater than -3 times -1? Okay. Well, if I go -1 times 6, that's a -6. -3 times -1 is a +3, because a negative times a negative is a positive. And if I know what I know about numbers in a number line, -6 is less than 3. So if we look at our inequality symbol, it went from greater than to less than. So we would say that our inequality symbol is reversed. We flipped it over. Okay? Let's do one more. Let's say I rolled the dice and I got a -1 and a 2. Okay? So -1 is less than 2. Don't know why I wrote -2. -1 is less than 2. And again, this time too, I'm going to multiply by a -1. Okay? So -1 times -1, is that still less than 2 times -1? All right, well, -1 times a -1, negative times a negative is a positive. 1 times 1 is 1. 2 times a -1, positive times a negative is a negative, so it's a -2. 1 is greater than -2. Positives are always bigger than negatives. Look at that. We went from less than to greater than. This also is reversed. Okay, so let's make our statement. When you multiply by, well, what do we multiply by? We multiply by a -1 each time. So when you multiply by a -1, the inequality symbol is reversed. Reversed. Hopefully I spelled that right. Okay. So now what we're going to do is we're going to see, does that hold true? Is it just a -1 thing, or does it hold true for other things? Okay. So flipping it over to the next page, we're at station 3 right here. And in station 3, we're going to be multiplying and dividing. Okay, so -2 is greater than -4. It's further to the right on the number line. Now we want to multiply by a half. Okay, so if we took -2 times a positive 1/2, negative times a positive is a negative. Half of 2 is 1. That becomes a -1. -4 times a half, negative times a positive is a negative. Half of 4 is 2. Well, notice in this case, our inequality symbol is preserved. So it's not just when we multiply. Okay, so if you were thinking that, hey, every time you multiply, we're going to flip the sign over, no. Okay, there's going to be something else to it. It's not too hard, though. Stick with me. All right, so let's pretend I rolled some dice and I rolled a -2 and a +2. On the number line, -2 is less than 2. So let's multiply each of those by 2. -2 is less than +2. So I'm going to go now multiplying by 2 here. 2 times -2. And I'm wondering, is that still less than 2 times 2? Well, a positive times a negative is a negative. 2 times 2 is 4. Positive times a positive is a positive. 2 times 2 is 4. Is -4 less than 4? Preserved. Not reversed. Preserved. All right, so now we multiplied by a fraction, by a +2, and it's preserving the sign. Let's try one more. This time we're going to divide. So let's say I rolled the die and I got -5 and a +1. Again, negatives are always going to be less than positives. Okay, so if I have -5 is less than 1, hopefully I said that right. Negatives are always less than positives. Positives are always greater. Okay, now let's divide both sides by 2. Okay, so I'm going to write division like this. Divide by 2, divide by 2. And even if you just grabbed a calculator for this, right? Negative divided by a positive is going to be negative. 5 divided by 2, I'm just going to use the decimal. That's 2.5, 2.5, right? Change it to a mixed number. 2 and 1/2. 1 divided by 2 is a half. Well, is -2.5 less than a half? Yeah, negatives are always smaller than positives. So this is also preserved. So now we were multiplying and dividing, but they're preserved. What was the difference between these numbers and these? I know these were all ones, but notice they were negatives. Okay, so when we make our statement here, what we're going to say is we are going to say that when, take the capitals off, when we multiply or divide, because it worked for divide, by a positive, remember I told you there's more to it, positive number, the inequality symbol is preserved. It's going to have multiplying or dividing and being a negative, okay? So if it's a positive, if you add, subtract, multiply, or divide positive numbers, inequality symbol stays the same. If you add or subtract negative numbers, inequality symbol stays the same. But if you multiply or divide by a negative, that's when we're going to reverse the inequality. Okay, so let's look at one more chart here, a couple examples to show that. All right, so you can see that we've been doing the same thing we're doing here. Okay, we multiplied by a -2. Negative. It's reversed. So let's say I grabbed a -1 and a 5. I'm sorry, a -5. Well, -1 is greater than -5. It's to the right of it on the number line. So let's multiply each by -3. So I'm just going to say, hey, -1 is, leave a little space, is greater than -5. And then I'm going to multiply them both by -3. Sorry, that's a greater than there, not a 7 if you thought it was. Okay, -1 times a -3. Negative times a negative is a positive. 1 times 3 is 3. Negative times a negative is positive. 5 times 3 is 15. And guess what? 3 is less than 15. We multiplied by a negative. Reversed. Okay. So let's say I grabbed a 2 and a 4. Or rolled the dice, right? 2 is less than 4. Now, let's divide by a -2. Well, a positive divided by a negative is going to be negative. 2 divided by 2 is 1. Positive divided by a negative is a negative. 4 divided by 2 is 2. Think of the number line. -1 is greater than -2. So we went from less than to greater than, and we're going to say that this is going to be reversed. Okay, and for the sake of time, I'm not going to do the last one because guess what? Anytime you multiply or divide by a negative, even if it's a fraction, it's going to be reversed. Okay, so let's make that statement. When you multiply or divide by a negative number, the inequality symbol is reversed. And I'm struggling to spell that word, reversed. Okay, so when we're practicing these inequalities, we're not worried about solving them, we're not worried about anything else. Use a number line if you need to, okay? Adding or subtracting, positive, negative, fractions, decimals, doesn't matter. Your symbol's saying the same. Anytime you multiply or divide by a positive number, whether it's a fraction, whether it's a whole number, it doesn't matter. Inequality symbols say the same. But if you multiply or divide by a negative number, that's when we're going to reverse the inequality symbol.